We are back in Lalac, Switzerland at a familiar place, but this time for something very special. The last time we were here, we stepped inside the Tudor manufacturer to see the full assembly process of a Tudor watch. But this time, we're going deeper. As part of Tudor's 100th anniversary, we are here visiting the brand, and they are opening not only their doors, but the doors of all of their suppliers to show us something that's never been seen before, the inner workings of the entire Tudor watch supply chain. My name is Danny Milton, Vice President of Content at Teddy Baldessar, and I can tell you, what Tudor is sharing is something truly unprecedented. And we're going to give you an inside look at how a Tudor watch is actually made. All right, so we're here at EMP. This is actually one of the suppliers that Tudor uses for its movement manufacture. To be more specific, EMP actually is part of the Kinesi family. So as you know, Tudor has a majority stake in Kinesi. So if you're going down the sort of supply chain, this is really what we're seeing. We're at the T0 level. And in the past, we've actually visited the Tudor manufacturer and we saw most of the assembly of the watches, but now we're actually seeing the T0 component level, full rolls of brass turned into these trays, and in French they call them barquettes. We actually saw a machine that can produce about 250 of these trays about every 5 minutes, which is quite incredible. So what we're seeing here is the MT56 family of calibers being made, and we're actually tracking its creation. And then we move on to the next level where we're seeing multi-axis CNC machines actually create those components and finish them. Now we're seeing the next step, what happens to those barquettes or trays. So there's two processes going on here at the exact same time. The creation of the gear train bridge and the creation of the main plate, both their creation and their finishing. Now in the case of the gear train bridge, you don't actually see it at its final step, which is sandblasting. However, you are seeing a functionally finished component. So when it comes to the gear train bridge, there's one multi-axis CNC machine, which is seeing its creation every 50 seconds. And we've been here for about 10 minutes, 15 minutes. About 20 or 25 of those have already been created in the time that we've been here. Once it comes out of that machine, there's actually someone who is doing a full handheld quality control check of the component to make sure that when it comes out of the machine, it actually meets the quality standards of the movement before it goes into a Tudor watch. It's important to remember that what Tudor is showing us here with EMP, one of a handful of suppliers, is that this is not an uncommon practice in the watchmaking industry. And while many brands use outside vendors for different parts of their own processes, the relationship to EMP is slightly different in that it's owned by Kinesi, which in turn is owned by Tudor. Now, having a specialist supplier of this kind ensures to Kinesi, and by virtue Tudor, a certain quality and scalability that it could not have otherwise. So now we're actually in a different facility as part of EMP, and what's happening here are levels of finishing are taking place both on the gear train bridge and on the main plate. What you're mostly going to see here is a lot of the engraving for the actual text that ends up on the gear train or the main plate. You're seeing the Tudor branding appear. Now on the part of the bridge, the laser engraving is both for text and for design aesthetics. So you're seeing this sunray effect on the bridge. For all intents and purposes, the main plate is just to engrave the Tudor word mark and a serial number which will be associated with the movement, not the watch itself, and that is essential for COSC certification. When you go back to the bridge, however, the steps that it takes in this room are not just relegated to the machine laser engraving, but actually goes one step further, where a person is actually stationed in this room doing diamond beveling. So that's actually being done by a single person, not by a machine necessarily. So this process isn't entirely linear. So after we see the laser engraving and the diamond beveling, the actual component parts, the gear train bridge and the main plate, leave this facility where they're rhodium coated or galvanic coated. That's what takes the brass color and turns it to a more silver coloration, almost looks like steel to the naked eye. Then it comes back here and goes to this next step where the pins and the jewels are set. So historically, watchmakers, they would actually try to play around with the regulation of a jewel for precision purposes, but now with the machines, you know down to the smallest levels, is going to be precise every time, both in terms of precision and just the angle and setting of the jewel itself. Once the jewels and pins are set, effectively, those components are complete and ready to go to Kinesi for full assembly. When it comes to precision manufacturing, tooling is expensive and highly consequential for scaling production. This is why it's important to note that these tools are made in-house. Without these tools, this work could not be done. Okay, so we're at another step in the process. We're actually at a different facility entirely. This is called Kennytech, and if that name sounds close to Kinesi, it's not any coincidence. Actually, if you look at the Kennytech logo, you'll see an association between the two. What's going on here is a very specific process, and it's two things. Hairsprings are being made here, and balance wheels are being made here, but there's a bit of a twist, and no pun intended, and it's actually part of the intention that Tudor has with Kinesi as part of this process. So when it comes to hairsprings, we're actually seeing the traditional hairspring method being made here in terms of the straightening and the spiraling of a traditional hairspring. It's actually quite a miraculous process to see happen live here. But the thing is, with the MT caliber that we're following, it doesn't use a traditional hairspring. That uses a silicone hairspring. That process does not happen here. And even if we were in the facility where it did happen, there wouldn't really be much to see because the silicone hairspring is created by a CNC machine and it comes out exactly as you input it into the CNC computer. And so we actually have an example of an assembled silicone hairspring in a balance wheel that is manufactured in this facility. The assemblage of the silicone hairspring in the balance wheel happens part of the time at this facility and part of the time in the facility where the silicone hairsprings are manufactured. But either way, the completed oscillator is returned to this facility before being shipped over to Kinesi, along with all the other movement parts we've already seen for the next stage in assembly of the completed movement. So what's really interesting about being in a room like this where the hairsprings are actually being turned into the spiral hairspring that you actually recognize is that while it's not used in the MT caliber in any Tudor watch, it actually speaks to Tudor's intentionality with Kinesi, which is to service other brands in the watch industry. So while Tudor may not be using it themselves, Kinesi does still supply hairsprings to other brands. So kind of a fascinating part of the story, even if technically speaking, seeing how a hairspring gets made isn't part of the story of the movement that we're following in this specific instance. All right, excuse the noise, but we are in a place that honestly requires it. We're no longer looking at movements, but we're now at the stage where we're making what are called case blanks. Now, differently than a movement blank, this is when you take a raw material and you end up with an unfinished case that would then go to the next step to have its traditional brushing and polishing and beveling. But for here, you're basically getting the natural shape and form of the front and back of the watch case. Now there's two types of case finishing that happen here. On the one hand, if you're dealing with stainless steel, you have what's called cold forging. When you deal with metals like titanium and bronze, you have something called hot forging. And the cold forging process starts with a long sheet where they cut out the individual case forms and then they start cold forging it. It's a stamping process that repeatedly creates the shape of the case. But in order to not have the case crack from repeated pressure on top of the case as it's formed, it goes through a process called annealing, which is a conveyor belt at about 1,000 degrees, where several, if not 50 or 100 cases at a time, go on a conveyor belt at high heat, which helps to soften the case and also strengthen the case, so when it receives that pressure again, the form is preserved and the cracking cannot happen. Now conversely, when we're talking about hot forging, we see the process on titanium cases that come out at high heat and are stamped with 240 tons of pressure in one stamping motion. This process is very interesting and complex, but you really get the sense of how a case is made. Now we even see a process that by hand, basically a single person is taking the case of our watch with the case back, putting 120 tons of pressure on it, and getting that traditional, iconic Tudor case back that we all see. All right, so the noise continues, but I think it adds to a bit of the ambiance and the vibe. And what goes on is a 12-step process in these CNC machines, where first you have the underside of the case, which is done in about 90 seconds. And what you're getting during that process is all of the threading in the underside of the case, as well as the threading for the crown. Then it gets turned over, and for about 45 seconds, you're getting all the threading for the top of the case for a bezel, for example, because in this case, we're looking at the manufacturing of both Pelagos and a black bay. And the titanium process takes a little bit longer than the steel process because, well, titanium is a harder metal than steel. But overall, in about 2.5 minutes, you have all of these tools giving you effectually all of the component threads and processes needed for the case to then move on to other steps in the finishing process, which we'll see later on in this facility. So behind me is the CNC machine that is used for the finishing of the bezel. So in this case, we're talking about a Pelagos 39. What's happening in the CNC machine is a multi-step process, one of which is the actual creation of the teeth around the bezel, and then all of the sort of component finishing of the threading underneath the bezel as well. From here, however, once the bezel is finished, we're next going to see how the case itself is completely finished, from satin brushing, to polishing, to chamfering. Basically, the entire case will be completed here before it gets moved on to the Tudor manufacturer in the lock. And while you may think that in a facility like this we're just talking about machine finishing, that's not the case. So what happens is there's a primer process where the case that we just saw goes into the CNC machine, sort of gets an initial finishing, then it gets moved over to the hand finishing component where the watch is mirror polished by hand by a single person. It then gets covered in sort of a lacquer material, a pink kind of varnish that protects the case when it goes back into the CNC machine for a process that is exclusive to Tudor called helicoidal brushing. Now, what's great about this lacquer, pink lacquer, is it protects the mirror polishing, but it also allows you to see that when you're doing the helicoidal brushing on the lugs, if you've missed any spots, there'll be pink residue left over to let you know that that's the case. But ideally, when it comes out, you have the helicoidal satin brushing on the lugs, the preserved mirror polishing on the case, and then when you want to remove that lacquer from the case, you just wash it off and it comes off quite easily. At that point, you have, in essence, a fully finished Tudor watch case that is ready basically for market. So we're looking at industrial watchmaking, but we just saw hand polishing, and here we're actually seeing the final stages of the watch case are also being done by hand on a hand-operated press that affixes both the bezel to the case, the crystal to the case, the whole thing complete, and what happens at the very end, you're seeing intricate steps being taken, like even the bezel alignment, making sure that that bezel is perfectly aligned for quality control standards, and then honestly, that protector you see when you buy a new Tudor watch, that goes on at this stage. The crown screws in, and what you have is a completely waterproof tested watch case ready to go to Tudor and Leloc for the movement to be inserted, and the watch is basically ready to be entered into the stream of commerce at that point. So it's really interesting to see that process happen, and we were able to watch a single person complete about 4 or 5 watch cases in the span of just a few minutes, all in what would be traditionally considered a handmade process. So while industrial watchmaking does create economies of scale for Tudor to be able to create and finish the cases and the movements the way that we've seen, it's a lot more intimate at the very end of the process. So this is the end of the life of the case now. The case is ready to go off to Leloc, and we'll be there to meet it later on in this trip. So now we're in another independent manufacturer that just makes bracelets. This company does make bracelets for other brands, but it also makes the bracelets for Tudor. And the process that we're going to see is effectively you have these long rods of raw material, but they're pre-shaped so that when they're loaded into these long machines, like you see the one behind me, it's basically CNC is coded to cut them, but they're pre-shaped and pre-curved. Where does that happen? In another supplier. That supplier has one job and one job only, to take raw steel or raw titanium and shape it for the purposes to come here and then get loaded into CNC and cut into very specific shapes. So right here we're looking at components of the clasp, and we'll see in other CNC machines throughout this manufacturer that each component part of the bracelet is basically made in the same process. All right, so we saw where those long rods were fed into CNC machines to make pre-shaped component parts. Those parts, when they come out of the CNC machine, they're not quite perfect, because when you're building a bracelet, whether or not it's a clasp or a link, it has to be entirely perfectly symmetrical at every point to ensure that every link and every part fits together to spec. So what you're seeing in this machine are the parts of the clasp are fed into this ribbed wheel, and they're all placed individually into the wheel and fed into the machine. That makes sure that each of the sides are perfectly smoothed out to ensure that symmetry, so when you build the bracelet together, you get that perfect fit. We're
actually where the dials get made for Tudor. So again, this is another supplier in the supply chain for Tudor, but it's really interesting because we're in the place where the dials get made, and we're watching a process where, similar to how we saw movement blanks and case blanks, there are dial blanks. The dial blanks are made completely out of sheets of brass, and there's a highly technical process here that they follow with step-by-step processes of where to stamp holes for the hands, where to stamp holes for a possible date window, and they feed through these intricate conveyor belt systems that are just continually stamping, refining, and polishing the process to even the situation where you're seeing the square rectangular blanks getting cut out in the circular openings into the brass dials that you know, and we're going to continue to follow the process to see how those turn into the recognizable Tudor dials. But in the same room where the dial blanks are being made, so too are the dial furnishings. So we're talking dial markers, applied hour markers, potentially applied Tudor logos, and those go through a similar conveyor belt system where they're being stamped out into small marker holes and eventually will become the recognizable hour markers that you know. But for now, this is very early in the process to make a dial, so you're basically only seeing round brass plates and little circles for hour markers. We're actually going to see a dial go from a standard Tudor Black Bay 41 from these dial blanks all the way to the finished dial process, where it would then get shipped over to the Tudor manufacturer in the lock for final assembly. So now we're at the next part of the process here. We're actually seeing how the dials get painted. This is really interesting. This is another handmade part of the process. So we watched as they mixed colors together very specifically so that they could end up airbrushing the brass dials that we saw get created from raw dial blank brass plates. And so over behind me, we're looking at dials for the Black Bay Chrono. We have the blue, we also have the flamingo pink dial as well. But this is just, it's so cool to see this process of the airbrushing technique to get these fully coated in that blue color that will eventually become one of the most popular Black Bay chronograph watches. So again, we're going to watch as these sort of dials grow into more recognizability with markers, etc. But watching the supply chain and seeing how these things are done by hand and not by machine, you might have thought that these would get brushed by a machine, but there was a person with an airbrush doing these dials, mixing the paint, so just another really cool part of the process. We're now seeing where the Tudor Black Bay Chrono we saw getting air painted is now actually having the sub counters cut out. Now you would think that would be a weird process to actually cut the counters after it's painted, because when you see them come out of the machine, you'll notice the counters are that raw brass color yet again. So intuitively you might have thought, well, why not just protect those two areas of the dial? But what they end up doing is stripping the paint away, and this CNC machine does two processes. It creates the 3D effect of the sunken counter and also strips away the paint. And while this is not a fully automated procedure, there's actually a person who is manning this process, and a lot of that has to do with the sheer quantity of the watches being produced. Now my understanding is if a watch had, let's say, 40,000, 50,000 dials in sequence, it could be fully automated. But the fact that there's probably 200 to 300 watch dials for these specific colorways of the Tudor Black Bay Chrono, there's actually one person who's checking to see, operating the machine, seeing as they come out whether they pass the test. And I think from talking to the team here, there's about a 95, 98% success rate with these dials. So it's really amazing to see this paint stripping, and now you can actually see the iconic layout of the two register chronograph for the Black Bay. We're continuing on with the life cycle of a Tudor Black Bay chronograph. The dials that we saw where they were stripped to have the brass sub-counters, and now what's happening is, before that process ever took place, there was protective varnish that was placed over the dial. So when the brass cutouts were made, it strips away that protective varnish and strips away the paint and prepares the watch for this galvanic bath process, where basically the dials are then placed into these baths for about 16 minutes. And in that time, that raw brass plate is going to be heated until it turns to an absolutely stark black color. So we're actually about 7 minutes away from seeing the flamingo pink dial come out. What was once a brass sub-counter is now going to be a black sub-counter. All right, so now we're actually seeing how a sunray finish is going to be put onto one of Tudor's dials. So the dials are actually delivered here in this general vicinity of this manufacturer. Then they're applied with a silver varnish, so now they look like this. They're brought here, where a combination of water and a limestone abrasive, and then a circular disc with brushes that go 360 degrees all the way around it, in various shapes and sizes, apply the sunray finish in what is a semi-automated process. So you'll notice these machines here with those circles on it, but there is a person manning every machine and making sure that the right mixture of abrasive to water and the brush is applying the symmetrical sunray finish to the dial. Those dials then have the silver color and the sunray finish, and then they move on to that bath process where they're going to be heated until they reach the black color that you would see on the dial. Now obviously, some versions of a Tudor dial where you have more of that matte finish, those are painted, but these are heated to the black color. Okay, so from the galvanic baths, we're now at the next step in the process, which is the pad printing on the dials. And we followed now a Black Bay 41, and we followed the Flamingo Pink Black Bay Chrono. And what you're seeing is these steel plates with the laser engraved dial on them. And there's a system whereby black ink, especially for the Black Bay chronograph, is being applied to the steel plate and then evened out and wiped away so that when the little pad actually touches the steel plate, it's picking up a print of the dial on it, moving an arm over to the dial and applying that to the dial. Now in this case, we're seeing this operation, depending on the situation, I've been told it can take more than one time. Here we're seeing the machine apply the black paint to the dial twice, just to get a clear and perfect application. And this process gets repeated over and over again. Now obviously on dials that would have more than one color, here we're only seeing black paint being applied. There'd be multiple processes that would need to take place. You'll notice here at this stage that the application of the black paint is only being pad printed onto the dial itself. There is no paint being applied to the sub-counters just yet. So these dials are really taking shape now, and they're becoming the recognizable Tudor dials that you know, because now we're at the stage of the process where the hour markers are being applied by hand, with loops in the eyes. It's a very, very, very finesse type of process that we're seeing. This room is probably the quietest room we've been in so far, because this is the kind of work that you really need to concentrate on. So we're seeing both hour markers being applied to the Black Bay chronograph in the Flamingo blue and also the Black Bay 41 in black. Now what's super interesting about this is to avoid any mistakes, you actually, when you apply the hour markers, you hear a small faint click sound, which means that the markers they have little feet on the bottom of them, almost imperceptible, and they fit directly into place, which is good because it obviates any error that could occur if hypothetically, let's say you have a 9 numeral and a 6 numeral. You wouldn't have a double 9 or a double 6 because the feet wouldn't fit in that process, and it would make you make sure that you have the dial as it's meant to be. Now once all of these markers are affixed to the dial and they have that little click motion, they're fed into a machine where they're laser soldered on to ensure, and this happens from the bottom of the dial, to ensure that all the markers are affixed perfectly and that they will never fall off when they're in your watch. Now we've reached the final step of the dial production process, which is the application of the lume. So there's actually a person who hand applies Superluminova. Now the Superluminova exists in powder form, and actually we took a torch to the Superluminova powder in the bottle and you can actually see it glow, but what happens in this process is Superluminova is combined with a glue, and that mixture, which we also torched and saw glow, is then fed into a tube system where it is hand applied to each individual marker, and you see these micro movements applying this luminescent material to the dial. So we learned that Superluminova is not an inexpensive material. I mean, it's 50 to 60 Swiss francs for a single gram of Superluminova. So you can understand, going through an industrial watchmaking process, any part of that process that can be done by hand is just fascinating to witness. And so seeing how this is applied is great to see, and having experienced, my own Tudor Black Bay 58, it's a pretty good application of lume. We're now in Kinesi, and Kinesi is Tudor's movement-making arm. It's how Tudor's able to make its in-house calibers, and we are in the place where that is happening. We've just been through the entire process of an MT caliber from all of Tudor's suppliers, and that supply chain leads us to here. And this is where the final movement assembly takes place. Now there's a really cool system here. You see watchmakers all over this room. There's a conveyor belt system that tracks along these desks here and delivers each movement to each watchmaker on a plastic tray, and that plastic tray has a specific RFID tag that can track the movement on its journey to completion and allows it to be part of the stream of where it needs to go from Kinesi to Tudor for final watch assembly later on. Now interesting here is there's a basic movement assembly that takes place, then the watch gets an auxiliary seconds hand put on and an auxiliary dial. And that version of the watch, which has no automatic winding rotor, it's a manual wind at that moment, gets shipped off for COSC certification. After COSC certification, the watch returns to Kinesi, gets into the final assembly with automatic rotor, and moves just across the walls over into the Tudor manufacturer where it goes into a watch for final watch assembly. It's a really interesting story just to see how we went from literally a movement blank, a piece of brass, a case blank, a dial blank, and we're seeing how it all comes together in real time. All right, so we're in familiar territory now on the Tudor side of the compound here between the Tudor manufacturer and the Kinesi manufacturer. You might notice we were here a couple years ago tracking and understanding Tudor's assembly process in this facility, but never with the full context that we just experienced. Because now, understanding that we've seen all the component parts in the Tudor supply chain come to this point, it really elevates the appreciation level for what we're seeing. So this room is sort of the marriage of craft and technology. So we're in a room that basically is impervious to dust. When we had to put on our jackets here and we had to put coverings over our shoes, it's all in the interest of keeping dust out of this space, because dust is the enemy of watchmaking. And that couldn't be more true, especially when we're in a facility that is fully casing these watches. That means that the dials and the movements are being sealed up in the case and you cannot have dust enter in there. Now this room, additionally, the conditions by which all the watchmakers are assembling the watches is sort of at the peak of where technology is for watch manufacturing today. That means temperature controlled. You have air being recycled every 3.5 hours, and the windows kind of play an interesting trick. So it kind of maintains a consistent lighting, so when the sun shines, the windows actually darken, and vice versa, so there's never really any interruption to the watchmakers in their process. Okay, so we continue to be on familiar territory here. We are on the Metas testing floor. This is when all of Tudor's 4 main pillars are being tested. According to the brand's 4 key pillars, which happen to be right behind me: precision, waterproofness, anti-magnetism, and power reserve. This entire floor operates 24 hours a day. We've been here before. You can actually see there are these fully autonomous robots that are transporting trays of watches from station to station, all in the effort to achieve the testing for all of the different pillars. What's I think different this time we're here from the last time is the robots have actually received a new coat of paint in pink and blue, which is reminiscent of 2 watches we've seen a lot today on our tour, which is the Flamingo Pink and Flamingo Blue Black Bay chronograph. So it's really great to see a floor that runs basically in the most autonomous nature of any aspect of the tour we've been on, 24 hours a day. Back again with our final bracelets being attached to the watch. This is the final piece of the puzzle, the final assembly, and once complete, the watch is placed in its box, it's tagged, and it gets sent into the stream of commerce.
So there you have it. That is how a Tudor watch is made from start to finish, truly. Now, while we did see about 5 different manufacturing facilities, the truth and honesty is there's probably 40 different suppliers that make a Tudor watch what it is, but for all intents and purposes, the important parts were hit on this tour. You saw everything from early movement making to a dial at its barest form, and it all came together in the Tudor facility. What made this so exciting for us is that we had been here before, but we had the ability now to expand on the story. And now when you look at your Tudor watch next time the way I do, you probably won't look at it the same way again.